Good morning. Let's go over a few of the questions that you were assigned for homework to make sure that we know how to do these angled projectile motion problems and be able to do them for our tests that we have on Wednesday. So it says a long jumper leaves the ground with an initial velocity of 13 meters per second at an angle of 34 degrees above the horizontal. Determine the time of flight, the horizontal distance, and the peak height of the long jumper. So I'm going to go ahead and draw my diagram so that I know what I'm solving for. So here's the projectile, and I need to solve for its range, which would be its x. I need to solve for the time, and I need to solve for the peak height, which is our maximum distance, or our maximum height. Okay, so anytime that you get a question that says an angle, you need to know that you need to break up our components. And we do that because we know that the x component and the y component of velocity are independent of each other. And the way that we learned how to do that is by using some basic trigonometry. So what I like to do is just set it up as a triangle. Okay, so I have my velocity that was given of 13 meters per second, and then we were given an angle of 34 degrees. Okay, I'm trying to make that a 4 and it's not working. Okay, how can I change the color? I don't know. Does this change the color? No. Okay, maybe this one? That looks like a highlighter. Okay, sorry. So we can use our basic trigonometry skills. We know that this right here is going to be our v of x component. And we know this on the triangle is our v of y component. Okay, we know that v of x is adjacent and that v of y is opposite. So we're just reviewing our trigonometry. In class, we reviewed that SOHCAHTOA is going to help us remember which to use, sine or cosine. So since v of x is adjacent to the angle, we're going to use cosine to find our v of x component. So it's vx equals v cosine of the angle, and then v of y is going to be v sine of the angle. Okay, so plugging in for vx, I'm going to do that right over here. We have 13 meters per second times cosine of 34. I'll plug that into my calculator. Got 10.7. Sorry that took so long. I had to make sure my calculator was in degree mode. So then my v of y is 13 cosine of 34. Oh, sorry. Sine. That's 6.27. Okay. And this is technically 10.78. All right, so that's finding the components. Okay, so now from those components, let's use them to help us determine the time, the horizontal distance, and the peak height. So I'm going to start with peak height because that seems to be the part that we struggle the most on. So to find the peak height, I have to remember that the velocity at the top of this path right here is 0 in the y component. Whoa, what happened? Okay, decrease. There we go, better. Okay, so with that fact, I can figure out the max height. So we've used this formula before, VF squared minus VI squared over 2G is going to equal our delta Y. So our V final is 0 minus VI, which is our VI and our Y component, all over 2Y. And I'm just going to use 10 because why not? And I got the height to be 2.16 meters. Okay? So if that's our max height, that means I can use that to solve for my time. So our free fall time formula, wow, what was that? Square root 2 times y over g equals time. Okay, so 2 times the y, just 6, not 2. Oh, I get what I'm doing. .73 seconds, but that's not it because you got to multiply by 2 because that's only half the height. I hope you guys remembered how to that. You have to do that. So I got 1.46 seconds. And from that, I can find the range by using our simple range formula. X equals VIX times T. We found our VIX to be 10.78 times the time, 1.46 seconds. And that's about 15 meters or 15.1 because I can already hear someone yelling, I got this. Okay, so our range, 15 meters, time 1.46 seconds, and the max height was 2.64 meters. Okay,